In this video, we will compute the probability of equally likely outcomes in application. So just a review of the definition of probability of event E. We take the number of elements in event E divided by the number of elements in the sample space, and we get our probability of event E. Just to note that E is a subset of S, so it's always true that our probability is between 0 and 1 inclusive. Let's take a look at an example. Suppose you roll a fair six-sided die. Determine the following probabilities. What's the probability of rolling a 5? Well, that would be the probability is equal to the number of ways to roll a 5 divided by the total possible outcomes. So how many ways are there to roll a 5 when you roll a fair six-sided die? 1. And how many possible outcomes are there when you roll a fair six-sided die? 6. So the probability is 1 out of 6. What's the probability of rolling a number equal to or smaller than 2? Well, similarly, we want how many ways are there to roll a number equal to or smaller than 2? So that would be 1 or 2. So how many ways are there to do that? There's 2 ways to get a 1 or a 2 out of 6 total. So that gives us 1/3 is the probability. Now, you can write probabilities as decimals or as fractions. However, when they're a repeating decimal, we try not to round, so keeping it in a fraction form is generally better. Let's look at a few other examples for calculating equally likely outcomes. Suppose you have 12 baseball caps and 28 fashion hats. If you pick a hat at random, what's the probability of picking a baseball cap? So the probability of baseball cap is how many ways are there to choose a baseball cap? So number of baseball caps divided by our total number of hats, or whatever we're choosing from, our total sample space, our total possible outcomes. So we have 12 baseball caps divided by all of them together, which is 12 plus 28, which is 12 over 40, which simplifies to 3/10. Now 3/10 would be okay to write as a decimal, 0.3, because it's nice and round. It doesn't repeat and we don't have to, cut it off around it. But it is an exact decimal. Let's try one more. Determine the probability that you choose a state in the US at random that begins with the letter I. So we want the probability that a state starts with I. So we want the number of states that begin with the letter I divided by the total number of states. So I happen to know that there are 4 states that begin with the letter I: Idaho, Illinois, Indiana, and Iowa. And I also happen to know we have 50 states in the US. So when we simplify 4/50ths, we get 2/25ths. And that's the probability that you randomly select a state in the US that begins with the letter I.